Hello friends, I am Bodhika Chetan and today in this lecture we'll discuss about discovery of prostaglandin and classification of prostaglandin. In 1935, the Swedish physiologist von Euler discovered a substance in human semen. Since it was secreted from prostate gland, he named that substance as prostaglandin. Later, it was found that prostaglandin was present in almost every tissue in human and other animals. Understanding of prostaglandin grew in 1960 and 70s with pioneering research of Swedish biochemist Bergström and Samuelsson and British biochemist Robert Wayne. They shared the Nobel Prize for Physiology or Medicine in 1982 for their isolation, identification, and analysis of numerous prostaglandins. Prostaglandins are made up of unsaturated fatty acids that contain a cyclopentane ring and are derived from 20-carbon straight-chain polyunsaturated fatty acids. Prostaglandins are very potent. Some prostaglandin act in an autocrine fashion, that is, stimulating reaction in the same tissues in which they were synthesized, and some prostaglandin act in a paracrine fashion, that is, stimulating reaction in the local tissue near where they are synthesized. In addition, a prostaglandin may have different and even opposite effect in different tissues. The ability of the same prostaglandin to stimulate a reaction in one tissue and inhibit the same reaction in other tissue is determined by the type of receptor to which the prostaglandin binds. When a blood vessel is injured, prostaglandin, called thromboxane, stimulates the formation of blood clot to try to heal the damage. It also causes the muscles in the blood vessel to contract to try to prevent the blood loss. Another prostaglandin, called prostacyclin, has the opposite effect to thromboxane, that is, reducing blood clotting and removing any clot that are no longer needed. It also causes the blood vessel to relax.
20 carbon compounds are synthesized from arachidonic acid, act as a local hormones in function, and widely used as a therapeutic agents.
Prostaglandins are the derivative of 20-carbon fatty acids, that is prostanoic acid. So here the structure is, it has a cyclopentane ring from C8 to C12 carbon atom and two side chain with carboxyl group at one of the side chain. Now we shall study about classification of prostaglandins. Prostaglandins are classified based on the following factors, that is, functionality related to cyclopentane ring, stereochemistry of hydroxyl group on C9 carbon atom, and position of double bond present in the side chain. So first, we'll go for functionality related to cyclopentane ring. According to this, prostaglandins are named as PGA, PGB, PGC, and so on. So let's see their structures one by one. In structure for PGA, there's double bond between C10 and C11 carbon atom in the cyclopentane ring and keto group at C9 carbon atom, whereas R1 and R2 represents the side chain in the prostanoic acid, that is R1 is from C1 to C7 carbon atom and R2 is from C13 to C20 carbon atom. In case of PGB, there's double bond between C8 and C12 carbon atom and keto group at C9 carbon atom, same as that of PGA, only there's difference between the position of double bond. In case of PGC, there is double bond between C11 and C12 carbon atom and keto group is at C9 carbon atom. Now, if we look at the structure of PGA, PGB and PGC, so there's only difference between the position of double bond in the cyclopentane ring. In case of PGD, hydroxyl group is at C9 carbon atom and keto group at C11 carbon atom. In case of PGE, keto group at C9 carbon atom and hydroxyl group at C11 carbon atom. And in case of PGF, hydroxyl group at C9 and C11 carbon atom. So let's look at all the structure, that is PD, PGD, PGE and PGF. In case of PGG, two oxygen atoms are present at C9 carbon atom as well as at C11 carbon atom and both are bonded together. Also, hydroperoxide group is present at C50 carbon atom, that is in the side chain. In case of PGH, its structure is similar to that of PGG. Only difference is it contains hydroxyl group at C15 instead of hydroperoxide group. In case of PGI, there is attachment of oxygen between C6 and C9 forming a 5-membered ring. In this case, R1 is C1 to C5 and R2 is from C13 to C20. This was about classification of prostaglandin based on functionality related to the cyclopentane ring. Now we will see about classification of prostaglandin based on stereochemistry of hydroxyl group of C9 carbon atom. This is structure for PGF1 alpha. F1 indicates it has one double bond in the side chain and alpha indicates that OH bond is below the plane. And if there is beta, then it indicates that OH group on C9 carbon atom is above the plane. So this was classification of prostaglandin based on hydroxyl group at C9 carbon atom. That is, if hydroxyl group is below the plane, then alpha is used, and if hydroxyl group is above the plane, then we use beta. Now we'll see classification of prostaglandin based on number of double bond in the side chain and their position in the side chain. So according to this, they are classified or divided into 3 series. In series 1, it contains one double bond, that is between C13 and C14 carbon atom. In series 2, it has two double bond in the side chain, that is between C13 and C14 carbon atom and between C5 and C6 carbon atom. In series 3, it has three double bond in the side chain, that is between C13 and C14 carbon atom, C5 and C6 carbon atom and C17 and C18 carbon atom. Prostaglandins are abbreviated by formula PG, XN, alpha or beta, where X represent A, B, C, D families, N represent number of double bond in the side chain, alpha represent OH group below the plane of ring, and beta represent OH group above the plane of ring. Prostaglandins are also classified into two groups, primary prostaglandin and secondary prostaglandin. Primary prostaglandin includes E, F, and I families, whereas secondary prostaglandin includes A, B, C, D, G, and H families.